Hello everyone, today we're going to talk about how to sort and classify quadrilaterals. So what is a quadrilateral? It's a polygon, which is a fancy way to say a shape that has four sides. So anything that has four sides, we call it a quadrilateral. We have some specific quadrilaterals we're going to talk about in this video, and there are two main ways that we organize them. So we can either have a family tree or a Venn diagram. I'll move my little face out of the way. Alright, so over here on the left, this is our family tree. So this is how we read our family tree. Up at the top, we have a quadrilateral, so everything below this, right, those are all quadrilaterals because they all have four sides. Now, we call it a family tree because it kind of has our little family branches, just like you'd see like a family tree with grandparents, aunts, and uncles, right? So the left-hand side of our family tree is our trapezoids. So our trapezoids have one set of parallel sides. We'll get into more of the details about that later. And an isosceles trapezoid is a specific kind of trapezoid with equal sides on either side. Then our other side of the family tree is our parallelograms. These have two sets of parallel sides. So everything below this is a parallelogram, and we have a rhombus has four equal sides, a rectangle has four 90-degree angles, and a square is kind of a combination of both of those things. So how do we read the family tree? You can see these kind of arrows with the always, sometimes, never, right? So always is going up. That means if I take something like the square and I ask about anything above it, right? Is a square a quadrilateral? That's always going to be true. Is a square a rectangle? That's always true because that's above it, right? If we're going down then, that's sometimes true. So let's go from quadrilateral to square. Is a quadrilateral a square? Well, sometimes, because some quadrilaterals are squares, but some quadrilaterals are not, right? We can also have any of these other kinds. The one thing that's never true is if we go side to side. So a trapezoid can never be a parallelogram and vice versa. The other way that we can organize these same shapes is in a Venn diagram. So it's kind of set up similarly, right? We've got one big circle, that's our quadrilateral, so everything in that circle is a quadrilateral. We've got our two separate groups again, right? Our parallelograms, which have our rhombus, our rectangle, and our square. And we've got our trapezoid, which has that special isosceles trapezoid in it. So how do we read this? If we are going out, right, so starting in the middle and going outside. Let's take an isosceles trapezoid this time. Is an isosceles trapezoid a quadrilateral? We're starting in, we're going to an outer one, so yes, this is always true, right? They have four sides, they're always going to be a quadrilateral. If we're going in, so let's go opposite, quadrilateral to isosceles trapezoid. This is sometimes true, right? Some quadrilaterals are isosceles trapezoids, but not all of them. And again, if we're going across, they can never be true, right? Parallelograms can never be trapezoids. So before we get into all the little details and properties of these quadrilaterals, we have to remember some key vocab. So let's take a look at that. The first one is parallel lines. So if you have parallel lines, those are two lines that are never going to cross. So think railroad tracks, shelves on a bookshelf, right? They are two lines that are side by side and will never cross, no matter how far you go. Perpendicular. Perpendicular are two lines that cross at a perfect 90-degree angle. We usually mark that with a little square. That square means 90 degrees. Bisect. Bisecting means we're going to divide it into two equal parts, just like a bicycle has two wheels, right? So these two lines, if they bisect each other, that means that this little part and this little part are equal, and this little part and this little part are equal. So they are cutting something in half. A diagonal is going to go diagonally across the shape, right? So it connects two opposite angles. That would be the diagonal of that rectangle. Adjacent means they are right next to each other. So these two angles that are highlighted in blue are adjacent to each other. This angle and this angle would not be adjacent. And then congruent is the same size and same shape. A lot of times we use markings to show that, right? So we've got this one marking here, one marking there. That means that those are the same size. Two markings and two markings shows the same size, so on and so forth. So now that we have our kind of vocabulary up to speed, let's take a look at more specifics about the properties of each of these kind of shapes. So up at the top, our big thing is our quadrilateral. We already talked about this. A quadrilateral has four sides, and we've talked about this in previous videos if you watched, but the interior angles are always going to add up to 360. So if I take this angle plus this one plus this one plus this one, they will always add up to 360. Let's start with our trapezoids on the left-hand side. So a trapezoid is a specific kind of quadrilateral, and it only has one set of parallel sides. We can mark those parallel sides with this little arrow, so I know that this side and this side are parallel to each other. So that is what makes that a trapezoid. You can see that this line and this line, if I were to extend them, those are eventually going to cross. So those are not parallel, which is what makes this a trapezoid. A trapezoid doesn't have any lines of symmetry. There's no places where I could cut this in half and fold it over and they would be the same. Now, an isosceles trapezoid is an even more specific type of quadrilateral. So it is a trapezoid. It still has one set of parallel sides, but it also has the non-parallel sides are going to be congruent, which remember is just a fancy way to say equal. So we've got that one set of parallel sides, and those opposite sides that are not parallel are going to be congruent. An isosceles trapezoid is going to have one line of symmetry. So if I take this and I cut this in half straight up and down, if I were to fold those two sides in on each other, they would be exactly the same. So that is our one line of symmetry for an isosceles trapezoid. All right, now we've got our trapezoids done. Let's look at our parallelograms. So there are four big things to remember about our parallelograms. The first two are that the opposite sides are always going to be parallel and congruent. And I'm going to mark that with our little tick marks this time, so I know that this top side and this bottom side are going to be equal. I know that these two sides are also going to be equal. The other thing we know is that opposite angles are also congruent. And I can show that using our markings as well. So I've got this angle and this angle are equal, this angle and this angle are equal. The last big thing is that diagonals bisect each other. So remember that a diagonal connects two opposite angles, right? So there's one diagonal, there's another diagonal, and if they bisect each other, that means that this side and this little side are equal, this side and this side are equal. A parallelogram does not have any lines of symmetry. There's no place where I can fold it in on itself and it's going to match up on either side. Okay, remember, as we're going down, we're just getting more specific. So a rhombus and a rectangle are both parallelograms. So everything that we just set up here is also true for our rhombus and our rectangle, I guess excluding our lines of symmetry. Let's first talk about a rhombus. So a rhombus looks like this. All sides of a rhombus are congruent. Now, we talked about all the things for a parallelogram are still true. So the opposite sides are still parallel, our opposite angles are still congruent, our diagonals still bisect each other, but in a rhombus, the diagonals bisect each other at 90-degree angles. That means if I were to draw those diagonals in again, oh, here, let me try that one more time. We can see that those cross at a 90-degree angle, so that is something specific to a rhombus. A rhombus has two lines of symmetry. So we can cut a rhombus across this way, kind of on its diagonals, right? And that would fold perfectly in half, or we could go this way, and that would also fold it perfectly in half. So a rhombus has those two lines of symmetry. Let's go on to a rectangle. So again, still a parallelogram, everything is true. The opposite sides are still parallel, the opposite sides are still congruent. But what's specific about a rectangle is that all four angles are 90 degrees, or we can call those right angles. So all four angles of a rectangle are 90 degrees, and that's what makes a rectangle look like a rectangle. The diagonals are congruent, and they still bisect each other just like a parallelogram. They do not cross at 90-degree angles like a rhombus, but they're congruent. Kind of like if you picture cutting a sandwich on that diagonal, right? You're going to have that same distance no matter if you cut it this way or this way. A rectangle also has two lines of symmetry. This time, though, they are straight up and down through the middle or straight across side to side. So those are your two lines of symmetry for a rectangle. Now, a square is like we took a rhombus and a rectangle and we put it together. So we still have all those properties of parallelograms, but we have the four congruent sides, just like a rhombus, and we have the four 90-degree angles, just like a rectangle. Our opposite sides are still parallel and congruent, just like all parallelograms. The diagonals are going to be perpendicular, so they bisect each other at those 90-degree angles, and they're going to be congruent. We also have four lines of symmetry for a square. So we can go diagonal, just like we did for our rhombus, and we can go straight up and down, just like we did for our rectangle. Okay, so now that we know a little bit more about all these different types of quadrilaterals, let's go ahead and classify them. So we're going to look at what properties we recognize, and we're going to talk about how we know what is what. So looking at this first shape, I can see that we've got one set of parallel sides but the other side is not parallel. So I know that this is going to be a trapezoid. Now, let's go back to that family tree for a second. If I have a trapezoid, I know that it's a trapezoid, but it's also everything above it. So it's also going to be a quadrilateral. And none of the rest of those are true. All right, let's look at number 2. This time we've got those 4 equal sides. If something has 4 equal sides, we know that this is a rhombus. So let's take one more look at that family tree. A rhombus has parallelograms and quadrilaterals above it. So a rhombus is also a parallelogram and a quadrilateral. All right, next up we've got a square, right? We've got the 4 equal sides, the 4 90-degree angles, right? So we know that this is a square. Now let's take a look at the family tree one last time, because this one has all of them, right? A square is also a rhombus, a rectangle, a parallelogram, and a quadrilateral. So everything above it is also true. So let's highlight all of those. A square is a rectangle, a rhombus, a parallelogram, and a quadrilateral. All right, let's take a look at these last 3. So we've got we've got this first one has opposite sides are equal. We've got those 4 90-degree angles, so we know this has to be a rectangle. And above a rectangle on that family tree is a parallelogram and a quadrilateral. All right, the next one, again, we have those 2 parallel sides, right? But the other sides are not parallel. So this has to be a trapezoid, but we also have that those opposite sides are equal. So this is that specific trapezoid, my isosceles trapezoid. Also a trapezoid and also a quadrilateral. And our last one has those opposite sides are parallel to each other, but they are not equal. We don't have any 90-degree angles, so this is just a parallelogram. And a parallelogram is also a quadrilateral. So the last kind of question we're going to look at is always, sometimes, or never. So they're going to give us a statement, and we are going to use that Venn diagram or family tree to say if it is true all the time, sometimes, or never. So first one, a trapezoid is a rectangle. Let's go look at that family tree. Okay, so we have a trapezoid over here and a rectangle over here. If we are going side to side, this is never true. So we will say never. And this is because trapezoids are only going to have 1 set of parallel sides, where rectangles are going to have 2 sets of parallel sides. Next up, a quadrilateral is a parallelogram. So looking at that family tree, we've got quadrilateral and parallelogram. So we are going down, which means that this is sometimes true. This is sometimes true because some quadrilaterals are parallelograms, but some are not. We can have trapezoids, we can have regular old quadrilaterals, so some are, but not all of them. Next up, we have parallelograms are quadrilaterals. Okay, so we're going parallelograms are quadrilaterals. This time we are going up. So this is always true. A parallelogram is always a quadrilateral because it always has 4 sides. Okay, I want you to pause the video here, and I want you to try 4, 5, and 6 on your own. So go back and forth between that family tree and these statements and see if you can figure out if they are always, sometimes, or never true. All right, and see how you did. So a rectangle is sometimes a square, right? We were going down on that family tree. So some rectangles are squares, but not all of them. On the other side, though, number 5, a square is always going to be a rectangle. So a rectangle has 4 90-degree angles. A square always has 4 90-degree angles. So that is always true. And our last one, a parallelogram is sometimes a rectangle. Again, we are going down this time. So some parallelograms can be rectangles, but they could also be a rhombus. They could also just be a regular old parallelogram. So it's not always going to be true. All right, so I hope you're feeling more comfortable with talking about those different types of quadrilaterals, how to classify them, and how to sort them. Have a great day, and I will see you next time.